Okay, this is 9709 42, question 5 over here. A car of mass 1250 kilograms is pulling a caravan of mass 800 kilograms along a straight road. The resistances to the motion of the car and caravan are 440 newtons and 280 newtons respectively. The car and caravan are connected by a light, rigid tow bar, and the car and caravan are moving along a horizontal part of the road at a constant speed of 30 meters per second. Calculate in kilowatts the power developed by the engine of the car. So obviously the keyword here is constant speed, right? So the power we know is equal to force times velocity, right? We know the velocity, we just need the force, right? We know V is equal to 30 meters per second from the given. We need the force. Okay, what do we know? We're saying constant speed, so sigma F is equal to 0, right? That means there's no A, because the A equals 0. Constant speed, that means there's no acceleration. So if you draw the FBD of the car caravan system, okay, you can draw it as a system. You have the weight, let's say weight total, okay. We can say that we have the driving force, or E. I like to call it E, okay, and we have the resistance total, okay, let's call it RT, and we have N. Type, what do we know that constant speed? That means sigma Fx is equal to what? 0. So E is going to be equal to R total, and R total is the sum of both 440 and 280. So you can use whatever you want, and this is the way I like solving. Okay, so E is equal to 440 plus 280, which is 440 plus 280, 720. Okay, so now you can apply P equals FV, so P is equal to 720 times the velocity, which is 30. Let's solve it. 720 times 30 is 21,600 watts, or 21.6 kilowatts, right? Okay, part A, very easy. Part B, or II, given that this power is suddenly decreased by 8 kilowatts, find the instantaneous deceleration of the car and caravan and the tension in the tow bar. So we know now that the power is decreased by 8 kilowatts. So power, the new power, is equal to our old power, let's say power initial, minus 8 kilowatts, right? And that means it's just 21.6 minus 8, which is 13.6 kilowatts. So this is our new power. What do we want? We want to know the instantaneous deceleration of the car and caravan and the tension in the tow bar. So we want to now find a specific force. So to do this, I recommend you draw the FBD. Okay, so let's draw our FBD. Over here, we have our Y, X. I'm going to say this is for, what's car? Is the big one, right? Yeah, car. This is for car. And then here is for caravan. Okay, and again over here Y, and over here we have X. Okay, let's start. So we can say the weight of the car. We have over here the driving force, or what I like to call E. Over here you have the normal reaction, and you have the resistance of the car, and you also have tension. Someone might ask me, why didn't you include tension over here? Here we're talking about the car caravan system, right? So the tensions cancel out if you're considering it as the whole system, okay? So that's why we're talking about the engine that moves both the car and the caravan. Here, we're doing car and caravan separately because they both have different FPDs, okay? But this is one big system, so the tensions cancel out with each other. Here, you have to treat them separately because you're looking at deceleration and you're looking for tension. You have to add the tension here. But in the first one, when you're treating it as one system, you don't need to separate and put tension because it just cancels out. Anyways, so this is the car for, let's say, weight of car. And this is over here, we're going to do the caravan, weight again of the caravan. You have the tension, which is pulling it to the right, and you have the normal reaction, and you also have the resistive force. Okay, just so you can have kind of a visual representation of how I'm imagining this. This is your caravan over here, and it's being pulled by your car over here, your big car. Excuse my drawing skills. So kind of imagine this, okay? Anyways, That's how it looks. So the tension is pulling the car back and pulling the Caravan forwards. Okay, this is R of the Caravan and this is R of the car. Let's start solving. We know that there is deceleration. Pay attention to the word instantaneous. So we're speaking about the instantaneous. So at this instant, we started at what? 30 meters per second. So velocity at this instant is 30 meters per second. Okay. So do you think we can find the force produced by the engine? Of course we can, right? P is equal to FV. We know the power that the engine is providing and we know the velocity, so we can definitely find the driving force, the E. Okay, so that means E is equal to the power divided by the velocity, which is just 13,600 divided by 30. Let's do this on a calculator. You get 453.33. So 453.33 newtons. Okay, let's start seeing. We're obviously decelerating. So over here, sigma fx, it's not going to be equal to 0 because we have an acceleration. Okay, so sigma fx is going to be equal to ma for both cases. So for the car, it's going to be, since we're moving to the right, obviously, E minus R minus T is equal to ma. Okay, this is for the car. Car. Okay, so let's substitute 433.33 minus the resistance of the car, which is 440, sorry. Let me hold this 30 up, it's a bit annoying. 30. Okay, so minus 440 minus tension is equal to the mass of the car, which is 1250 kilograms, times the acceleration. Okay, so we're going to set up a system of equations. We're going to do 453 minus 440. Let's simplify. So minus 440 is going to be, should be 13.33. Yeah, so 13.33 minus T is equal to 1250A. So we can set the equation to be T is equal to, if you move this to the other side, if you move this here and take T there, T is going to be equal to 13.33 minus 1250A. Equation 1. Okay, we're going to call this equation 1. Ya Allah, hold up. 1250A, we're going to call this equation 1. Type. How about for the Caravan? We know that it's moving to the right, so also sigma fx, so this is for car. For Caravan, it's going to be also sigma fx is equal to ma. Okay, so therefore T minus R of the Caravan is equal to the mass of the Caravan times acceleration. Let's fix it. So T minus, how much was the resistance of the Caravan? 280 is equal to the mass of the Caravan, which is 800 A. So we can set T also here to be equal to 800A plus 280. This is the way I like solving. You can solve these two equations whatever way you like. Okay, so T equals 800A plus 280. So now I have two equations for T, right? This equation, equation 1 and equation 2, and I can just equate them to each other. So that means 13.33 minus 1250A is equal to 800A plus 280. Solve this equation and you should get 13.33 minus 280 divided by 2050. You should get A to be negative 0.13 meter per second squared, and then T is just equal to, you can use either one of these. I'll just use 800A plus 280 is equal to 800 times 0.13 plus 280. So 800 times negative 0.13, right? A is equal to negative 0.13. So 800 times negative 0.13 plus 280, and you get 176 newtons. Okay, so you can say here decelerates at 0.13 meters per second squared. Or the instantaneous deceleration, let's say instantaneous deceleration is 0.13. Because I said deceleration, you make it positive, okay? So instantaneous deceleration is 0.13 meters per second squared, okay? And the tension is 176 newtons. So put a box around this so your corrector can kind of see that this is your answer. Let me show you the marking scheme. The answer is A equals negative 0.13 meters per second squared and T equals 176. If you get this, keep it negative, عادي. Just show that you got A equals negative 0.13 meters per second square and then say this, you'll definitely get a full mark. To stay on the safe side, I always put both. I always put A, the value of A I get, and then I say the rate of deceleration is 0.13. Okay, that's to guarantee that I get the full mark, I always put both. Okay, and T equals 176 newtons. Part B. Okay, the car and caravan now travel along a part of the road inclined at sine inverse 0.06 to the horizontal. The car and caravan travel up the incline at constant speed with the engine of the car working at 28 kilowatts. Find the constant speed. So remember, when we say constant speed, that means sigma fx is equal to 0 because there's no acceleration. Okay, so let's start. We know when we're looking at the speed, the same way we did for part A, when you're referring to the system, you neglect tension, okay? But let me draw it so you can kind of see what we're looking at. Always when you have an inclined plane, draw it. Alpha, right? This, we can say alpha, and we have our system over here. Y, X, right? The weight going down. Okay, to draw the FBD, it's Y, X, okay, the weight goes down, and there's an angle alpha over here. We know that we have Wx and Wy. Okay, we know that the engine produces a driving force of E, that I like to call E, they call it dF, and we obviously have the resistance forces from the car and caravan that they said are always 440 and 280. Okay, so what do we know? We know sigma fx equals 0, right? So sigma fx is equal to 0, so that indicates that E is equal to Wx plus RT, right? Why am I finding the force? Because remember, to find the constant speed given power, P is equal to force times velocity, and we can say the force by the engine. Always when you're using E, just put a note, the force by the engine is E. Or if you want to use, instead of E, dF, then you won't have to do this, okay? E is equal to Wx plus RT. So E is equal to, what's Wx? It's mg sine alpha plus the total resistance. Okay, let's continue over here. E is equal to the mass. What's the total mass? 1250 plus 800, so 2050. So 1250 plus 800 is 2050 times g, which is 10, times sine alpha, which is given as 0.06. Okay, plus the total resistance, which is 440 plus 280. So you should get that E is 1950. Let's check. 20500 times 0.06 plus 440 plus 280. You should get 1950 joules. We know P is equal to FV, so the power given, 28,000, is equal to 1950 V. So V is equal to 28,000 over 1950. Let's do it. 28,000 divided by answer. You get 14.3. Is that correct? Yeah, 14 point to three significant figures, 14.4. Right? So 14.4 meters per second. Find the increase in the potential energy of the caravan in 1 minute. So to find, pay attention, we're only talking about the caravan now. To find the increase in potential energy, we need to know how much height did he travel. So that's why here we found the velocity. So if we're moving at v equal 14.4 meters per second, how much distance do we travel in 1 minute? Obviously d is equal to velocity times time. So 14.4 times 60, which is over here, let's do it, 14.4 times 60 and you get it 864, okay, meters. Okay, we know that potential energy, considering the bottom, considering we started at 0, right? So delta U, it's equal to U final minus U initial, and we're going to cancel U initial as 0 because we started at the bottom of the plane. Okay, what is U final equal to? U final is equal to mgh. What's the mass of the Caravan? Okay, please, we're only considering the Caravan. Don't solve for both. The Caravan is 800 kilograms. So U final is going to be 800 times G, which is 10, times the height, which is always the height when working with an inclined plane is the distance traveled times sine of the angle. So 864 sine alpha. And we know that sine alpha is equal to 0.06, right? Yeah, 0.06. So we're going to do 800 times 10 times 864 times 0.06. So 800 times 10 times 864 times 0.06, you get 414,720. So delta U is equal to 414,720 joules. But since you used an answer that was rounded, okay, this is how Cambridge works. Since you used an answer that was rounded, okay, 14.4, that means you also have to round this, okay, to 3SF. And when you round it to 3SF, it's going to be 400, so delta U should be 400 to 3SF, it should be 4.15 times 10 to the power of 3 joules. Okay, the way they did it is they put 414 kilojoules. I'm not sure why. So let me take a look. So I just checked why. Why you can't? Why this is wrong is because the velocity you use, you have to use the exact value. So you can't use the rounded value. My mistake, huh? So over here, when you use a value that you rounded up, you're not allowed to use that, okay? If you put it as an answer, okay, that's perfect, it's fine, you got 14.4. But using that in another part, it's wrong. You have to use the exact value of it, and that was 28,000 over 1,950. Let's see how much that is. Maybe we can get a simpler fraction. Over 1950. Yeah, 560 over 39. So you have to use velocity as 560 over 39. So you can do 560 over 39 times 60, okay, which is, let's just keep it as 11,200 over 13, so that we can get an exact answer. 11,200 over 13. Always do this when you're working with a value that isn't exact. You need to keep on using fractions, okay? So times over here 11,200 over 13. 11,200 over 13. And over here we erase this. Let's see how much do we get. Okay, 800 times 10 times the answer we got times 0.06. You get 413,538. So it's equal to 413,530. So this is a very long number. It's not exact. For that reason, we're going to round it to 3 significant figures. So it's going to be 4.1, let me show you, see, 4.14 times 10 to the power of 5 joules, right? Or, this is correct, or you could say 414 kilojoules. These will both be accepted, okay? Even though it only says 414, this will definitely be accepted because it's the same thing as 4, okay? It's the same thing, okay? Either one of these. That's it for this video. Thank you so much for watching and good luck.